Hello everybody, my name's Chris Ward and I'm one of the product managers for the Control product business, and in this worked example I intend to take you through the ground fault monitor function which is integrated into the SIMOCODE system. So this isn't about programming the device right through from the start of the application. So if you do want to do that, please refer back to one of my other videos demonstrating how to program a DOL or a reverser. So in this example, we're going to jump into the ground fault and explain how that works and why you'd want to use it. So ground fault monitors and serves as an early warning system. So basically it provides operators with the information they need in order to plan appropriate maintenance measures. So measuring the resistance of a system in insulation to ground enables detection of both symmetrical and asymmetrical ground faults. And when the actual ground fault occurs, the pathway to ground immediately becomes unrestricted with no resistance, and this causes like a massive influx of current flow. So when a ground fault causes current spike in this way, the circuit breakers can trip and it can shut off the power, and also it can damage your motor. So the idea is that if you put preventative measures in by using this ground fault protection, it'll protect your system in a much more effective way. So I'll show you how to use that. So if we go into the control device here and we go into the parameter set, as you can see here, there's a few different options. What we need to do is go into machine monitoring. You can see this bottom option here is ground fault monitoring. So in ground fault monitoring, there's a trip level and there's also a warning level, and we can decide how they react to that. So we can set, say, a trip level from anywhere between 10 and 120%. We might want the trip level to be 70%, and we want the response to that to either signal or trip. Normally when it's the upper threshold, we want to do something a bit more drastic to prevent any damage to the motor or preventing the device from tripping out the circuit breaker. So if we go and select a trip for that, a reason why you might have a delay on there is that if you've got slight deviations in your current, which is how this device monitors ground fault, it adds the summation of the currents up to figure out whether there's any discrepancies. If there's a quick fluctuation, you might want to put a delay on there so that you don't get any nuisance tripping. For the warning level, you might want to have this at slightly lower. So you might want that at 40%. And how would you like to react to that? Well, you probably wouldn't want it to trip, but you'd want it to signify a warning to an engineer to say that the device has been breached in terms of it's going towards the upper limit, and it's getting to a dangerous level, and it could perhaps cause a trip. So the idea is if you're using both of these levels, you're using a trip level and a warning level, it's giving the maintenance engineers plenty of time to be able to go and rectify the issue before it actually reaches this trip level. So you're predicting maintenance before the problem actually occurs. So once you've done that, you can download that into the SIMOCODE station, and then you'll have a fully functional ground fault functionality, which will be integrated into the SIMOCODE station and ready to go and to be tested. So I hope you found the video useful, and please stay tuned for more videos in relation to how to program the SIMOCODE station. Thank you.